In this tutorial, I'm going to show you the steps to create a forest of trees using Blender's new geometry nodes. In this video, I'm using Blender 2.93. The first thing we're going to do is create objects that we can use in our geometry nodes to represent the tree trunk, the branches, and then the leaves. So we'll delete this cube. For the tree trunk, we'll use a cylinder. And we'll shade that smooth and add a couple of subdivisions. And then we'll scale it so it's skinnier and taller. And I'm just going to make the bottom of this a little bit more brought down to the edge of the cylinder. So that's Shift E for the edge crease. And with that selected, I'm also going to move the 3D cursor down there so we can set the origin. So right now it's in the middle of this part, but we want the origin to be at the bottom of the branch. So anytime we are instancing this branch, it's going to be easier to control rotations and scaling if we have the origin at the bottom. So right click, set origin to 3D cursor. And then we'll move the cursor back to the origin, and we can add a plane, which we can use as the leaves. And I'm just going to set one subdivision on that. Then we'll just apply the scale, and we'll use this auto smooth for the normals so the bottom of this doesn't look weird. Alright, now we'll just move these out of the way, and we'll create a ground layer. So in this case, we can just use a plane. This will represent the earth or the ground where the trees will grow out of. So now we'll go into the actual geometry nodes. So to get there, you can hit this plus sign at the top, go to general, and then at the bottom, geometry nodes. So this is the default layout for geometry nodes. In the top right, you have your viewport. In the top left is a list of all the points in your geometry. So you can see there's 4 of them, and that's representing, if I go into edit mode, each of these points on this plane. So X, Y, and Z. In the bottom here is where we actually do the geometry nodes. So to create a node network for this object, we're going to hit this new button. And now you can see we've created a node network, and it has a input where it's getting the geometry data from this object, and then it's connecting to an output, which there's nothing going on in between right now, so it's outputting the same geometry. So the first thing we want to do is distribute points along the ground, our plane here, and that's going to represent the locations where trees will be growing from. So if we do Shift A and go to point and point distribute, you can see our plane has now turned into some points. And if we increase the density, you can see we're adding more and more points as we increase. And if you go really high, you can see eventually you'd have enough points to fill a plane. But for now, we're just going to keep it really low. And another thing we can do is change this random to Poisson disk. And what this allows us to do is actually control the distance between points. So this is good for something like a tree or a forest, where the trees won't be growing perfectly next to each other, we can actually increase that value. So if we increase density, you can see as I move this down, but I'm still increasing density, it's only going to put points where the minimum distance is greater than 0.25. So for making it easier to see what's going on, I'm going to reduce this density down to 1 point. And on that 1 point, we want to make the tree trunk appear. So to do that, we can create a new node, and that's going to be the point instance. So the point instance allows us to select an object. You can either click this box and you have all your objects here, or you can click the eyedropper and choose an object. And you can see now we have a tree trunk. And if we increase the density here, you can see we get more. But we lost our ground. So in order to be able to see the ground, we can connect this geometry to here, but you can see now that's got rid of our tree trunk because it's bypassing all this. So what we need to do is create a new node which will connect all these options. So a join geometry, and you can see on the left side this is like a pill-shaped connector versus a circular connector, and what that means is you can connect as many outputs from these into that connector. So now you can see we're getting both our plane coming from the original geometry, as well as the instanced tree trunk. So again, if we increase that, we can still get the ground and we have our trees. So the next thing we can do is control the scale of each of the tree trunks. And the way we can do that, I'm just going to move these apart because we're going to put some stuff in the middle. We can use an attribute randomize node. So attribute randomize. And you can place it right here on the line between the point distribute and the point instance. And we're going to change this to a vector so we can control the x, y, and the z. And right here where it says attribute, in this box, if we type in scale, we'll be able to access the scale property of this object. So this is like a built-in attribute for Blender. And you can see right now it just kind of shrunk it down. So it's picking a random value in x, y, and z, and scaling it down to that. So we don't want that. So what we can do is change the x and the y to something that makes sense for a tree trunk. So maybe we'll do like 0.8, and so our minimum and our maximum will be the same for the xy. That's how thick the trunk is going to be. If we keep the minimum of the z-axis, the z-scale, at 0, as we're making our forest, we could have an issue where we're creating a tree that has 0 scale, and that's just unnecessary because it's not gonna show up. So let's make the minimum some value that's higher than 0. Maybe like that. So 0.26, and the maximum value will be whatever we want. But it's hard to see right now because we don't have enough trees. So let's actually increase the density a little bit. All right, so now we have tall trees, short trees. I'm actually going to drop down that height a little bit, maybe increase this one. Yeah, so we have some variation there. All right, let's drop this back down. So the next part we're going to do is create branches to come out of the tree trunk. So the way to do that is to create another point distribute. So if we do Shift A, point distribute, and put that right on the line here, you'll see that along the tree trunk, we've now created points, but we've lost the tree trunk. So if you increase here, we're getting a point, or a lot of points on that trunk. However, we need to have the tree trunk still there so that in the final output, we'll have a tree trunk and not just floating branches. So we can connect this geometry from the point instance, the one that was creating the tree trunk, and connect that to the output, so this join geometry. So if we do that, now we have a tree trunk with little twigs on it. Right now they're just points. And just like we did with the tree trunk, if we create a point instance, so Shift A, point instance, oops, and connect that on the line. And if we choose the same object, we can choose this tree trunk again. You can see now we have tree trunks on tree trunks. But they're kind of like branches. So what we want to do is obviously scale the branches, these branch objects, much smaller than the tree trunks. So we're going to, again, use an attribute randomize. Attribute randomize. And we'll change that to a vector again. So just for now, we will set this as 0.2. This is kind of like just guessing and checking to see what looks good. We need to put again, the scale attribute here. So this is the built-in attribute, or built-in property of these objects. Okay, so now we're looking a little bit better. And we can change the scale, the minimum length of the branches. So you can see as I change that, they get smaller. 0.01. That's still too big. Maybe 0.005. And we'll drop down the maximum. Maybe something like that. So since these are kind of the main branches of the tree, they're going to be a little bit large compared to the actual tree trunk. I might actually move the tree trunk thickness a little bit down, maybe like 0.6. 0.6. Yeah. So if we wanted more branches or less branches, you can change this density attribute. So we'll just keep it like that for now. So another thing that's going on here is you can see all the branches are just coming out radially from the tree trunk. So we want to change the rotation of those. So the way we can do that is with a attribute randomizer, but for the rotation instead of the scale. So attribute randomize, connect that there, change this to a vector, type in rotation this time. So again, this is a built-in property. You can see we already have something, but they're all going the same direction. That's because it's randomizing all of them between 0 and 1. If we change the z, the max z here, to a really big number, that will make sure that all of this is rotating around the entire tree trunk. I don't really know exactly what this number translates to in terms of like degrees or radians, but it just seems like if you go really big, you're more than, you've gone around the circle hundreds of times, so it does some good randomization. Now we can also change sort of the angle of these branches, of like how much they're kind of pointing up towards the sun. We can change that with this value. So you can see as I go like much larger, there's just like so much randomization there that they're just pointing up and down and all over the place. But if we keep it small, like closer to 1, you can see we're getting some some good control of how much the branches are pointing upwards. And you can change the minimum here too if you want to get like, I don't know, if you're making like a cactus or something and they're all like pretty uniform. But for now we'll just do that. So now we have a tree trunk with branches, and if we were to increase the density of the trees, of the trunks, you can see we're getting, these branches are being copied on all the instances of the tree trunk. So now we want to create what I'm going to call the small branches. So we have the tree trunk, the large branch, and then we'll create some more branches on the smaller ones. So what we can do is actually just copy this exact network here, and then just change the scale and the rotation. So if we select all of those and duplicate it, take the output of this point instance and put it into the geometry, but leave this this connection up to the join geometry, because remember, if we got rid of that and connect this here, you're just going to get instanced like floating points, floating twigs. So to actually get the large branches back in the view, you have to make sure it's connected there. Now you can see the branches are all kind of going in the same direction. The way this rotation attribute works is a little weird. I don't fully understand exactly what's going on, but instead of replacing the rotation, we want to just add to it, and that will make sure all the branches are rotating, like, I guess you can think of it like a local space. So if the big branch they were on is like, let's take this top one for example, this here. If that one's pointing upwards, we want the rotations to be applied for each of those points, independently of the rotations that, say, the big branch down here has. So from that, we can sort of change some of these values so that they're maybe sort of pointing upwards. And we have too many, I think, so we'll decrease the branches. And we want to change the scale. So first of all, the thickness is too much, so we'll bring down the minimum, maybe to like 0.01. And we'll bring down the maximum to 0.08. That looks all right. And then the length of the branches, we'll kind of make that a little bit shorter like that. There we go. So that's looking pretty good. Maybe we can increase the density of the small branches a little bit. Nice. Okay. So the next thing we can do is put the leaves on the branches. So again, on a real tree, the leaves kind of start coming out of the smallest branches. So you could potentially, if you wanted, create even like a third branch. So you could duplicate this and create another branch. But just to save computer resources, let's use these smaller twigs as the point instance for the leaves. So similar to what we're doing with the branches, we're going to do the same thing but with the leaves. So we can change this from the cylinder, from the tree trunk to the leaf, the plane of the leaf. And we'll connect the output there. And we'll move this over for organization. And then connect this point there. And because the density is so low, it's not really popping up, but if you increase the density here, you can see we're starting to get some leaves. Now, the leaves might be too small and there's not really a lot of variation in the size, so I'm actually going to change this to a float. We don't need so much control in this instance because it's just a flat plane. So if we increase the x, y, and the z as the same number, it'll have the same effect as controlling the numbers individually. So maybe for the minimum we'll put 0.1 for now, see what that looks like, and then for the maximum, let's do, alright, 0.1 is too much, let's do 0.05, and the maximum we'll do like 0.15. Yeah, it looks alright. And there we go. So again, you can change the rotation, you can do some randomization there. Just bump these numbers up really high and you'll get more and more randomization. Alright, so now we have kind of the basis of a tree. We can adjust any of these parameters. So if we wanted more leaves, you can crank that up. If you wanted more branches, you can crank that up. Small branches, you can crank that up. And you know, the more you increase it, the more it becomes a plant-looking thing. So now let's talk about how to make the canopy, so like the height of where the leaves actually start. Like in real trees, or a lot of trees, they don't have the branches coming out at the very bottom. I'm thinking like, you know, big tall trees in a deciduous forest, for example. Those are going to be, those canopies are high in the air, and they're not coming down all the way down to the floor here. So in order to see what's going on, let's scale our floor up a little bit so we can get a few more trees. So scale it, and then you have to apply the scale. And because of our density values here in our point distribute on the tree trunks, you can see we're actually like able to spawn new trees. And because the heights are similar, the point distribute on each of the tree trunks is being applied the same for each instance. So in order to change that, I don't understand exactly why, but if we create a attribute randomize node right after the point instance and change that to rotation, now all the trees are different and unique. So there's probably a good reason why that's happening, but like I can't change this value. It doesn't do anything with the rotation, but it makes each one unique, so it serves its purpose. Just trust me, that works. So in order to get the canopy, what we're going to do is create a system where we sort of like cut the tree in half. So we will say that anything above a line, a certain height, will be allowed into this point distribute, and anything below it will be ignored. So in order to do that, we we need to create a a plane that we can use as that check to see, is it true or false if a point is above a plane. So what we can do is actually use our original ground plane as a as that check. So if we do a point translate and take the output of the original geometry, so remember that's just our plane, and connect that, and then if we connect this to our final geometry, you can't see it, but it's actually created another plane there. But if we increase the Z here, you can see now that plane is up in the canopy. So we can use this slider to change where that canopy is going to start. Now obviously we're not doing the check right now to see if the values should be above or below this. So in our branches, our initial branches, we're going to add a attribute separate node, and what that's going to do is separate the x, y, and z of our points. If we type in position here, which is a built-in property, now we can say, all right, if for any given point, the output of z, so like a z point, so the values in this third section, we can create our own custom attribute. So I'm going to call it z position. So this is a custom attribute. This is not built in. But now we can reference this value here, and anytime we reference it, it's always going to be the z of any point in this point distribute. So I'm just going to create a little bit more space here. It's starting to get pretty crowded. And we want to be able to check if the z position is above this canopy line. So I guess I'll explain this by adding the math node first. So we'll add an attribute math, and you can change this add function. So you can click this drop down and choose less than. So what this is going to do is take a value. So we'll use z position. So that's like the z position of all the points. And then some other value. For now, we can just use a float. We're going to change this later, but just for an example of explaining this a little bit easier, I'm going to use the float. And the resulting value, again, is we'll create a new attribute. So I'm going to call it z canopy. So it's kind of like the z position of the canopy. And at the end of this, all of these attributes here, if we create a point separate, what this is going to do is take all the outputs that are true and output them out of geometry 2, and all the outputs that are false go out of geometry 1. So for the mask, that's our z canopy. So it's basically saying like anything that was greater than the z position of this B value is not going to be applied into the Z canopy. So, and I might have that backwards, but you can see as we change this value, we're actually adjusting the height of that canopy. So um, that's cool, but trees don't all have the exact same starting point for that canopy, right? So that's why we're going to bring in this concept of using this plane as a way to put some variation there. So um, instead of using a float value here, we're actually going to use an attribute. So, and bear with me, I know this is a lot to take in, but so we're going to use an attribute proximity node. Blender doesn't have a lot of references of how to use a lot of this stuff, so it's pretty confusing, and uh, you know, thanks for following along. I hope it's helping out. But anyways, attribute proximity, we'll add that in this area here. And we need to create, let's expand this so we can see what's going on. We need to create some values for the distance and the position. And basically what this attribute proximity is doing is saying in the geometry that's coming through, so these points, if they are close to the faces of some target geometry, so we're going to use this canopy plane. If those points are close to the target, then we can output their value of distance or the position. And I'm not exactly sure like what the difference between those are, but we'll just create attributes for both of these. So we'll call it canopy distance, I guess, and then canopy position. And we'll take the output of this point translate, and just so we can see what's going on, we'll leave the geometry connected of that plane, but we'll connect this as the target. So now we have, again, the faces of this plane are the target, and so as a geometry of these points is close to that target, it's going to output that value into these attributes. So if we use one of these values here in our attribute math node, we can use canopy distance, for example. If you just start typing, it'll show up. So now you can see it's not exactly like the same location, because it's kind of like the closer these values are, the more dense, I guess, or the distance value is lower. So as we increase this translation here, this Z translation, now we're getting the same kind of concept as we were when we had a float in the attribute math. So what this is allowing us to do is now put some noise into this plane so that we can adjust the heights or randomize the heights of the canopy and where those are starting on the trees. So on the geometry of this point translate, we can create an attribute randomize. So Shift A, attribute randomize, and connect it on the line that's going to the target. And if we change that to a vector, and we'll choose position, and we'll leave the X and Y as 1. So that the X and Y position is like, looking from the top um, where's that position relative to the original plane, and then the z is the the values of the z direction. So we actually have to connect this line here. And when we connect that, you can see the plane disappeared and we lost our points. And that's because we're using this to replace and create. If we change this to add, now we're changing the we're actually adding values to where the points are instead of creating new points. So we're actually going to have this as 0 and the max is 0 for the x and the y. And we can create variation in the z like that. So now we're kind of starting to get some variation in our canopy. If we want more geometry, so more subdivisions in the canopy, we can do that by adding a subdivision surface that's in the mesh category, and we can put that before the point translate. So it's going to subdivide the original plane, and if we look from the top, you can see it's become kind of circular. So if we use this boundary smooth and turn that off, now it will stay with the same aspect ratio. So if we increase that level more and more, you can see we're adding more and more noise to the canopy selector. If we put too much in, we're not going to be able to see the level of detail like across the trees here in terms of like where that canopy begins and ends. So now it's just a matter of playing with the height of the canopy and how much variation you're putting in those points and where the canopy's beginning. But you can see now we're starting to get some variation in exactly where the canopies start. I thought I just saw one. Oh, that's the instanced one. Okay. So now, um, for kind of looking at that, I you can just delete that and get rid of it, but I kind of like keeping that so I can always just go back and turn it on. So what I've found you can do is create a transform, so geometry transform, and put that here. And then if you add a value node, so that is in input value, and connect that to the scale. If you type in 1, it's going to give you the view of the same canopy going through, but if you type in 0, now it's got a scale of 0 and it's gone. So this is kind of like a little toggle that I've made to sort of hide that if I want some debugging, and then I can put it back in to see where the variations are. So this is helpful like if you're making a big forest and you want to see exactly how that canopy is behaving without actually having to like draw and reconnect across this huge network here. Alright, so now we can start to add some materials to our trees. So let's hide the canopy for now. And we can go into the shading tab. So to add material to the leaves, just click on that, click new. Hopefully if you guys are doing geometry nodes, you guys know this stuff already, but we'll just make it some green, Maybe we can even do something fancy, put some randomization in it with a color ramp. Do some sort of green and maybe a little yellowish. Connect that. Sure. And then for the tree, we can do the same thing. Let's use a little bit of like a brownish color for now. And there we go. Now we have some trees. So another thing we can do here, so you have to click on the object to get the geometry nodes back. Another thing you can do is sort of take some of the inputs. So think of like the density or the scale. We can take those and put them into, we can like connect them back into this input, and then they're going to show up on the right panel here. So you can have access to those much more conveniently. So just as an example, we'll connect the branch density out to there. And you can click this little arrow here, and you can see all the inputs and outputs. Make sure you're selected here, this group tab. And you can change the name if you click that. So this is the density of the large branches, so maybe we call it density large branch. And you can see that appeared over here in the modifier properties tab. So if we wanted to, maybe in our layout, if we wanted to change the density of large branches, we can do that right here. So maybe we change it down or increase it. There we go. On my final version, I have all of the inputs from my geometry nodes connecting back into this group input, so that anything I want to control or automate, like in the rotating forest I had at the beginning, you can do that. So yeah, that's pretty much it. If you have any comments or questions, feel free to leave them below. And thanks for watching.